Welcome. This video is CCBYCN. Welcome back. We're going to talk about solving trigonometric equations today. It can get a little tricky. You'll want to have your unit circle handy for some of these. We're going to start with a relatively simple one. We have tangent squared of x equals 3. And so what I need to do is take the square root of both sides. And remember that when I do that, we get both plus and minus root 3. Now, we are limiting our answers between 0 and 2 pi. Now, remember, 0 and 2 pi are 4 quadrants. 2 of them, tangent is positive. That's quadrants 1 and 3. And 2 of them, tangent is negative. That is 2 and 4. Now, we want all of them. We want the positive root 3's and the negative root 3's. And so here's what I'm going to do. Here's my root 3. That's pi over 3. So this is how I'm getting these answers. So my next negative root 3 is there. That's 2 pi over 3. Down here, down at 240, or 4 pi over 3, with the positive root 3. And over here, here's my negative root 3, down at 5 pi over 3. Now for this one, it ends there. There's going to be some other equations in a bit where we don't have this limitation and we want all of them. You could see that if I wanted to go to the next angle, the 7 pi over 3, I would get another one, but 7 pi over 3 is bigger than 2 pi. So we're limited in this case. Number 2. I'm going to notice that we have a cosine in both. So I'm going to factor out a cosine. Cosine x. So just like an algebra equation, I'm going to set each piece equal to 0. Now this one's already solved for, and where is cosine equal to 0? Cosine is x. Cosine is equal to 0 at pi over 2, and down here at 3 pi over 2. Now this one needs a little work. We're going to get the sign by itself. And we're going to note that we want to know when sine x equals a positive 1/2. So here are 2 of our answers. Now, when is sine equal to a positive 1/2? Now, remember, sine is the y. And sine is positive in quadrants 1 and 2. And so when does sine equal 1/2? Well, that's when y is 1/2. So I'm here at pi over 6. By the way, we know that it's in radians because they say between 0 and 2 pi. If it said between 0 and 360 degrees, then you would want the degree answer. But that's implied. Pi over 6. That's in quadrant 1. In quadrant 2, I'm over here. 5 pi over 6. So this one has 4 answers, just like the previous one. So you're really going to want to have that unit circle with you as you're doing your homework. Example 3. Here we have sort of a quadratic-like equation. I have 2 something squared minus 3, that same something plus 1 equals 0. I'm going to compare this to if I had 2y squared minus 3y plus 1 equals 0. And then I'm going to factor that. 2y, y. I'm going to do exactly the same thing with this here. but instead of y, I'm going to use sine. And just like I would do with an algebraic equation, with this one, I'm going to set each piece equal to 0 again. And now I'm going to get the sine of x by itself. And push this down just a little bit so we can see there's a similarity here. So sine of x equals positive 1/2. There are two values between 0 and 2 pi. Let's find them again. Remember, sine is the y coordinate. When do we have positive 1/2? We have it right here at pi over 6, and we have it over here at 5 pi over 6. Now, for sine of x equals 1, that's when y equals 1. That is going to be up here, the y coordinate at pi over 2. So you can see in this case, there are 3 answers. Not too bad. Let's move on to number 4, example 4. There we are. Now in this case, we have a sine squared x and a cosine x. What I'm going to do is I'm going to use a rule. I need to get them the same. I can't have a sine and a cosine mixed like that for this type of problem. So I'm going to say, I'm going to use my Pythagorean identity and rewrite sine squared x as 1 minus cosine squared x. This comes from the sine squared x plus cosine squared x equals 1. I just subtracted the cosine squared x to both sides. So here we go. And now I need to kind of put it together. So I'm going to distribute the 2. Now I'm going to combine up my like terms. And I'm going to be honest with you, I don't like that negative in front like that. But what's nice is I can just go through and divide by a -1. Or multiply by -1. It's the same thing. What that does is that changes all the signs for me. I'm now going to factor this like I did the other, like it's quadratic. And it looks like we're going to have plus here and minus here. However you learn to factor in your algebra class, any method that you learn, and there's lots of them out there, it should work just fine. So here I have 2 cosine x minus 1 equals 0, and cosine x plus 1 equals 0. So 2 cosine x equals 1, cosine x equals -1. All right, let's start with this one. Cosine is positive in quadrants 1 and 4. And here we're looking for all values of x. So we're going to have to handle that. So what I'm going to do is find the 2 that are in quadrants 1 and 2. Now remember, cosine represents the x coordinate here. Whereas at positive 1/2, I'm up here at pi over 3. And I'm down here at 5 pi over 3. So I'm going to get pi over 3 and 5 pi over 3. Now here's the thing. When it says all values of x, that means that we need to add or subtract 2 pi to it, to both. So this is when k is an integer. So we can add a 2 pi, subtract a 2 pi, add a 2 pi, subtract a 2 pi, add a couple of 2 pi's, subtract a couple of 2 pi's, it doesn't matter. All of these represent all of the solutions. Now, when is cosine equal to -1? That's the x coordinate equal to -1. That's here at pi. So x equals pi plus 2 pi k again. Because again, it can just keep spinning around and around and around and around. And this is where k is an integer. If you forgot what an integer is any whole positive or negative number. So this is the answer that we're looking for. Remember, when you're adding or subtracting 2 pi, that just means you're going all the way around the circle once and ending up in the exact same spot. So we're getting all of the coterminal as we do this. So k can be 0, k can be 1, can be -1, 2, -2, and so on. The next two are going to have the same set of rules where we're looking for all values of x. So for this one, we have the tangent of x sine x plus sine x equals tangent x plus 1. Now, I'm going to get all the terms to one side. So I'm going to move this to the other side. So here we have the tangent x sine x plus sine x minus tangent x minus 1 equals 0. And if you remember from algebra, we now have to do what's called factoring by grouping. I'm going to take the first two and notice that there's a sine of x. And I'm left with tangent of x plus 1. And here I'm going to notice I can factor out a -1. And I'm left with tangent x plus 1. And now I'm going to notice that I can factor a common factor of tangent x plus 1 from both. I will be left with sine x minus 1. Here we go. And to be clear, this is the sine x minus 1. And what we factored out, the common factor, was the tangent x plus 1. And if I come up to here, I get tangent x plus 1 equals 0, or sine x minus 1 equals 0. I'm going to solve each of those. So I want to know where tangent is equal to -1. Tangent is negative in quadrants 2 and 4. So for tangent is equal to -1, I'm at 3 pi over 4. And I'm down here at 7 pi over 4. Now notice it wants all values. So I want to do this. X is 3 pi over 4. Now, I want to show you what's happening here. So we're going to here, 3 pi over 4. Then we're adding 180 degrees to that to get to 7 pi over 4. Then I can add 180 degrees to that, and I'm there. And it just keeps on going. So in reality, all I have to do is just keep adding pi each time. So I'm here, add pi, now I'm here. Add pi, now I'm here. Subtract pi, now I'm here. Subtract pi, now I'm here. So what I'm getting as an answer is going to be 3 pi over 4 plus k times pi. Again, same k as before, where k is an integer, where we're just adding and subtracting as many pi's as we want, and we're still getting the same answer. When is sine equal to 1? Sine is equal to 1 when y is equal to 1. That is up here at pi over 2. And I can add as many 2 pi's as I need to. And again, this is where, and I'll write it a little bit differently than I wrote it up here, is equal to 0, plus or minus 1, plus or minus 2, and so on. So this is how we get all of the solutions. And you'll need to check with your teacher how strict they want that written. Do they want it in this form or this form? Or there's even a more mathematical form that you can do where k is an integer. If you wanted to. Moving on. Example 6, this is another factoring by grouping. I'm going to notice that for the first two, I can factor out a sine squared. I'm left with a 2 sine squared x. I'm left with 2 sine x plus 1. And here again, I can factor out a -1. And very nicely, I can pull out that 2 sine x minus 1. I'm left with 2 sine squared x minus 1 equals 0. All right, so we've done this one a few times actually. So I'm going to add a 1, and 1. Divided by 2. And these look like they're going to be similar answers, but they're actually not. Here I get sine squared x equals 1/2. And I got to go a step further here. Take the square root. Square root of 1 is 1, root 2 is root 2, but when I rationalize it, I get root 2 over 2. So I'm going to rewrite this here. So sine x equals 1/2, and sine x equals plus or minus root 2 over 2. So in my back, sine represents y. Y is 1/2 at pi over 6. And remember, sine is positive in quadrants 1 and 2. So pi over 6 and 5 pi over 6. Again, this is all solutions. So this is pi over 6, 5 pi over 6. This is going to be plus 2 pi k again. Now this one wants all of the root 2 over 2s. I have it at pi over 4 right here. I have it at 3 pi over 4. I have it down here at 5 pi over 4 and over here at 7 pi over 4. Do you see actually it's every pi over 4? So when I'm here, to get to here, I'm actually adding a 90 degrees. And to get from here to here, I'm adding 90 degrees. And from here to here, I'm adding 90 degrees. So in actuality, what I can do is say it's pi over 4 plus pi over 2. Okay, that's 90 degrees, right? So I'm just adding 90 degrees, 90 degrees, 90 degrees, and so on. So here are our solutions. This is x equals and x equals. And again, we're k. It's there. I know it's a little weird, but if we want all the solutions, we have to account for it this way. Right. We are up to number 7. So here I have 3 cotangent squared x minus 2 cotangent x equals 1. And now we're back to between 0 and 2 pi. So I'm going to subtract a 1 to both sides. And once again, I'm going to factor it. And that is going to give me minus there and a plus there. This means 3 cotangent x plus 1 equals 0. Cotangent x minus 1 equals 0. So you can see I'm going to subtract a 1 and divide by 3. Negative 1/3, right? Subtract 1, divide by 3. Add a 1 to both sides. Now, if you remember, cotangent is the reciprocal of tangent, which means I can flip both sides to get tangent x equals negative 3. I could even do it here. Tangent x equals 1, because reciprocal of 1 is just 1. And I'm going to rewrite this over here. Tangent x is negative 3. And when is tangent positive? Tangent is positive in quadrants 1 and 3. And when is it tangent equal to 1? At pi over 4. And down here at 5 pi over 4. Now here we can get exact answers. Here, not so much. Here's the problem. I'm going to use inverse tangent. Now I need to be in radian mode. So you got to check your calculator. If you're in degree mode, it's not going to work. You're going to have to change that. You're going to have to fix it. All right, now here's the problem. They want answers between 0 and 2 pi. And let me show you what's going to happen when I do this. Inverse tangent of -3. You see it's negative? That is a problem. So what I'm going to do is I'm going to, let me show you kind of geometrically what's happening here. I am taking the inverse tangent. And because it's -3, it's giving me the angle down here as a negative angle. So it's going this way. And I don't want it to go that way because that means that it's a negative value, specifically that negative value. So what I'm going to do to get to the exact same spot is I'm going to add 2 pi to it, and that'll get me into the positive. So watch what happens. Plus 2 pi. There it is. Now I'm in quadrant 4. So let me write this out. So when I do get x, that's about -1.249. This is not between 0 and 2 pi. So I'm going to take x and I'm going to add 2 pi to it, which is going to give me, in my fourth quadrant, 5.034. There's one of my answers. We don't have an exact version for this one. Now, again, tangent is positive in quadrant, negative, pardon me, in quadrant 2 and 4. In quadrants 2 and 4, it's negative. We just found the angle in quadrant 4, wherever it ends up. It's not one of these. So what I'm going to do now is I know that wherever this angle here is, what I want to do is get the same angle over here. So this is just adding pi to that number. So I'm going to take that number and I'm going to add pi to that. And that should give me in quadrant 2. And it does. So x plus pi will give me the one. So this is in quadrant 4. And by adding pi, I got 1.893. And this is the angle in quadrant 3 in radians. That one you're going to have to take some time to really kind of think about it and push it around a little, because we want that angle as well as that angle. So if I get the negative of that and I add pi to that, that should get me right there. Or 2 pi to get the first one here that I have. These two are going to, these last two are going to do something similar to that. So we'll get a little bit more practice with that as well. Number 8, I'm going to use that trick that I used before, where I have cosine squared, but I have things in terms of sine. So I'm going to go off to the side here and just recall that cosine squared x is 1 minus sine squared x. We use that a lot, actually. So I'm going to go ahead and replace -5. I'm going to replace cosine squared x with 1 minus sine squared x. I'm going to distribute the -5. And I'm going to combine up my like terms. And this factors into and sine x plus 2. Again, make sure you factor however your teachers taught you before. Now what I'm going to do is I'm going to set each one of these equal to 0. I'm going to add a 1 and divide by 5. Here, I'm going to subtract a 2. And before I get going on this one, I'm going to have to use the calculator again with some of the same logic we used for the previous one. Sine of x cannot equal anything bigger than 1 or less than -1. So right away, this one is out. I don't have to do anything with it. If it's bigger than 1 or less than -1, don't have to worry about it. So sine is positive in quadrants 1 and 2. 1/5 is not on my unit circle for sure. So I'm going to have to use inverse sine to do this. And very nicely, when I do inverse sine, it's going to give me one of them in quadrant 1, which is between 0 and 2 pi. So inverse sine. Before I do that, let's double check that we are in radian mode, which we are. So inverse sine of 1 divided by 5. Yay, here's one of my answers. All right, so now I need to get, let me give you a bit of a drawing so we can see it. We've gotten our angle in quadrant 1. However, I need to get the same angle, but in quadrant 2 that has this. What I'm looking for is that angle. So here's what I'm going to do. I'm going to go all the way to pi and then subtract that number. Use my memories for a second here. I'm going to store this. Let me show you how I'm doing this. I'm going to take this number and I'm going to store it, STO, store it, and all these little letters above, A, B, C, and so on, are memories. I'm going to store it into, I have to take the green first, alpha A. So now it's stored in there. And what I like to do in my notes is mark up where I stored it. So now what I'm going to do is I'm going to do pi minus x. And that'll go pi all the way around and then minus this angle here, this 0.201. So here we go. Pi minus alpha A. There it is, quadrant 2. There is my other answer. So you have to really kind of think about what it is that you're doing. If you need to draw it out like that, you can do that as well. You also need to know what quadrant sine is positive in. A lot going on here. Last problem. So we're going to run into a similar problem that we had with tangent, where because it's negative, when I do inverse sine, it's going to give me a negative answer as I look at that. So let me do a bigger drawing here for what we're trying to do. And I'll do this. It's going to give me this angle in quadrant 4. However, it's going to give me a negative angle. Let me demonstrate that for you. So inverse sine. Let's once again check radian. Inverse sine of negative 0.45. Now I want to point out I am using the negative button down here. I'm not using the subtract button. If you use the subtract, it won't work. It won't like that. All right, and you'll notice it gives me a negative angle. It gives me a negative 0.467. Now, sine is negative in quadrant 4. It's also negative in quadrant 3. So what I'm going to do is I'm going to take this value and I'm going to add 2 pi to it. By the way, I'm going to store this off again. Remind you how I did that. I'm going to store it into A again. So what that's going to do is it's going to erase the old memory and put in this new one. All right, so that's going to give me x was about negative 0.467. And what I need to do is add 2 pi to that. 2 pi plus x. So A plus 2 pi. And there I am, quadrant 4, but it's positive. It's between 0 and 2 pi. So there's one of my solutions. Problem is, sine is negative in quadrants 3 as well. So that makes this angle here still 0.467. Now, I have stored off negative 0.467, which is not going to be as helpful. So here's what I'm going to do. I'm going to go pi plus. But because I have it stored as a negative, I'm actually going to do pi minus minus 0.467. So pi minus negative 0.467. Essentially, I'm adding it. So pi plus, I should say minus a, because a is still negative. And there I am in quadrant 3. And so this is 3.608. Yeah, that's how you solve some equations. All right.